Hi guys, welcome to another video in this series on the Formatables Refactor. Now I'd said I was actually going to do some coding without recording to see if I could speed things up, but as it turns out I ended up not having the time, and now I thought I might as well just continue recording. So if you remember, on our last video we finally managed to get rid of the locator configuration. We still have a locator. In fact, we should probably be clocking. We started about 5 or 6 minutes ago. So we still have a locator, and now the objective of this video is going to be to create a transform which starts to populate the parts, sort of inverts the way the locator works, if you see what I mean. It's going to start populating the path from a transform inside of the physical model using the meta model properties. So there's two things that need to change. The first thing that needs to change is the locator at present is being called to compute the full path and also to compute the include path. We need instead to have the transform to do that. And the second problem, well, actually, no, it's not much of a second problem. What we'll do is we'll just go to the physical model. We have a path transform which is currently being worked on. So we could just create another one here, and we just call that the legacy path. Portuguese keyboard transform, and we'll make this guy responsible for both include. We need to manually change colors because we don't have Python anymore, sadly. It's not too bad really. Right, so interestingly enough, it seems that the new classes have got less contact points. Used to have one here, now it's only one at the bottom. Oh well, we'll just go for a straight connection. Provided it is actually straight. Ah, we don't have snap to grid, that's why. Right, there we are then. So we're just going to create a transform here that has the job of populating the paths, and we'll need a context, which is just an imparam, and we'll need a model, which is the thing we're going to populate. Slightly confused. I'm not sure why this didn't work. Let's try again. Okay, this new version of Dia seems very buggy actually. I'm not entirely sure what is the problem. One more reason for us to start to get even keener on moving to oh yeah, it's populating now. Moving to a text-based format. It does seem this version of Dia is a bit buggy. Ah, so it seems like every time we choose the direction there, change it to in, it seems, yes, it seems to cause a problem. Okay, we don't really need that, to be honest, so let's just stick to what it is. And seem to have caused problems in several places as well. Right, so this is really bad news, really. We will just leave it as it is. And, I mean, I could downgrade to the previous version of Dia if I really have to, but I'm hoping we can just hold on. Okay. Right, so let's just try to see if we can get this thing to work. So the problem appears to be that, so if you just put no options at all, that seems to work fine. If you change that to in and out, that seems to break. So basically, do not use those properties for now. Okay, cool, no worries. So we'll do that. The problem is that the packages that we've got for the legacy version of Dia require Python 2, and it seems those packages are not available by default in the Debian unstable at present. So we can't easily downgrade without having to faff around with the package manager for a bit. So we're going to have to try our best to work with this this version of Dia best we can, and until at least we move to the text-based model. Right, so where are we then? We need to create a legacy path transform. The legacy path transform, let's just try to work this out perhaps with a bit of paper. The legacy path transform so it's going to loop through all the meta model items in the physical model, and then it's going to determine for a given meta model item whether that meta model belongs to one of the groups of archetypes the locator currently treats specially. So these are going to be CPP headers, CPP implementations, and so on. CMake lists. These will all be methods in the locator that we can use to determine which one's which. And then for each of these, we'll compute the path, and then it will update. Right, so this is the other bit where we need to bear in mind how this works at present. So the path at present must be calculated. Where is the locator being called from? So presumably we know for sure that the template calls the correct function to create the path. Here we are. And then somebody will be calling the full path. Now I don't think we have a transform as such. I wonder if it's something really silly like the assistant. Probably is actually. I think, actually we're just there. I think what's happening at present is that transforms can't quite remember how this code hangs together. Somebody has to be responsible for asking each model to text transform to compute the path. Now I know that we got some weird logic around the assistant. Okay, so we are relying on the fact that artifact properties is already populated with the file path. So the assistant is not doing the clever work. That being the case, somebody in the Formatables model, is there a path transfer? Ah, okay, we have file path and guard expander. Right, so this guy here, presumably, must be asking. Yeah, here we go. So here we are. So what we do at present is we locate the model to text transform that's associated with the artifact, and remember that artifacts are instances of archetypes. So when we got the archetype, presumably we must do a search. Here we are on the container with all the model to text transforms. We obtain that container, and then we ask that guy for a full path. And then of course, as you've seen, that then means that each model text transform has the right dispatching here to the right guy, and it will call the right function in the locator via this crazy magic that we have in the template parameters that we're passing into the mustache template. So for instance, here we'd have some, well, presumably maybe these guys are all defaulted. So if they're all defaulted somewhere around here, as you can see here, make full path for C++ header as the function it will call, and if it's an include file, we'll also call the right function. So okay, that's all looking good. So all we need to now know is make sure that includes bit is computed here too, and it is. Okay, so the two functions are here. So it all makes perfect sense in terms of the legacy world. We just need to create something that's similar to this, but instead of going to the model text transforms, it must somehow determine the right kind of the artifact and do the right thing. So what we'll do is we'll just quickly generate everything. I mean, I probably should have made sure we're running with a up-to-date code generator, which we're not. Make sure we run all tests, and then generate everything. Okay, right, this is broken probably because we just changed the physical model. So Dogen dot physical JSON. Right, so then what we'll do is we will just commit this as is. So generate skeleton for legacy paths transform. As I said, it's a habit to always commit very slowly and incrementally. It just makes life easier when things break. So if we just take any transform from here, it doesn't really matter which. All gonna have a very similar interface. I mean, we could honestly, it's just not enough hours in the day, but by now we could have created some templates that generate the transform skeleton properly and so on. But we just don't have enough time to do the things that would make our coding life easier. Which is a bit sad, really, because if we did that, it'd probably take a lot less time. Just like we have sort of these snippets for things like oxygen and so on. It'd be nice if you could do the same thing for transforms. So populate the include and full path in artifacts. Righty, so now then, what we'll do is we'll just create a very basic skeleton of the transform. This probably will be an interesting thing to do. I think there'll be a few problems. It's not quite as straightforward as it may sound. We need a trace, we're going to need some kind of model I/O. That's probably enough to get us going. And you see where we end up always trouble is we always copy and paste the logger setup. And this is what eventually comes back to bite us when we forget to update the pasted code. Right, so here we are. It's a very basic transform, and then for good measure we'll hook it in. Now let's think about the right place for this transform to go. Clearly it has to be done after the meta model properties transform, but presumably it can be done anywhere in the model population chain. So we'll just hook in the transform, and we'll just put it next to the current path transform, because we can easily here switch between one and the other, if you see what I mean. And that should solve the immediate problem. Okay, now then, Of course, at this point, nothing bad should happen. Right, so what is the transform going to do then? In fact, I should put a comment here. Oh, sorry. What I meant to do is this. So, we will go through the physical model, and for each, let's think, for each artifact in the physical model, sure I understand what's going on here. So a physical model is made up of regions. The regions have artifacts. So for each artifact, we shall determine the type of the artifact. Now that will be really easy because all artifacts will have a meta type, which enables us to hook in back to the physical meta ID, and we just need to bundle the meta IDs into groups. We could, if we're lazy, think about this, we could have an enum that maps to the different kinds. It's just a temporary thing really, but it would be useful because it would allow us to then know what the archetype kinds are going to be. I think I might go for that actually. I mean, this is just temporary, but it does then nicely map to the things. I mean, we've done something similar with technical spaces. If you see, at the moment we have an enum for technical spaces. We know for sure this needs to be data that will be injected in, but for now it's better to do it that way because we're modeling the types and then we know what types we have available. So what we can do is you can just create a temporary archetype kind. Of course, we need to maybe a legacy archetype kind, I guess. And then we put all the different kinds in there. And could really go anywhere. But in fact, to be honest, to be fair, probably should we go out. Well, I was going to say next to archetype kind, but this is already a very congested diagram, so that's not possible. In which case, we'll just go somewhere random like here. So let's say there's a legacy archetype kind, and that's going to be a MASD enumeration, and we should say something like kinds of archetypes available across all technical spaces. And then here we start to do the different kinds. Now at the moment, well, to be honest, what we'll do is we'll drive the kinds from looking at the locator. So if I look at the locator and look at the different things I see in the locator, so I see a C++ header, I see a template, I see C++ main. Right, so okay, so there's a test C++ implementation as well. Because of course the problem we have at the moment is we're going across parts and everything. It's actually really dodgy, but to be honest, we should really not let's not think too much about this, because the more we think about it, the more we start to realize how bad this is, and we have to remember this is temporary so we can move forward. This is not really a creative exercise. So interesting that we have a full path for solution, full path for Visual Studio solution. I wonder why. Ah, okay, so one is the full path for solution, and then the other one is the actual, so for the directory the solution is contained. So all we need to do is to make sure we capture all of these different kinds of archetypes we've got. And it may not be very nice, but we must remember that this is just the next step on the hard coding. Make it slightly more generic, slightly less hard coded. And eventually we'll have the proper data-driven approach. So just make sure we don't get too hung up on the badness and instead focus on getting out of the woods. Right, so these are all the different kinds of things the locator is dealing with at present. Now I think the templates will have something like no, we don't. I thought we have something else here with templates. Not obvious why not. I thought we'd have something like... Well, what we'll do is we'll just, now for a laugh. I mean, we may not necessarily need all of these, but we'll put them in and then remove whatever is left. Right, so here we are. Can't quite remember what color enumerations tend to be. They are F2D. So really is annoying that we have regressed from where we were. Dia was actually working quite well, but now we seem to have gone back. Right, so the legacy archetype kind, of course we need more of these for C#, but for now that would do. Now similarly to what we done a second ago, where we just co-generate this guy with the usual singing and dancing for the conversions. As you can see, we do a lot of commits. This is really by design. We don't really want all this stuff to go in. It's just so we don't end up with a one big commit with lots and lots of generated code, and then we can't really see the wood for the trees. For legacy archetype kinds, it's much better to have all the stuff that's co-generated committed separately. We know for sure this doesn't break, and we don't really have to worry about it. And then when we do have a commit, it has real work in it, with a very, very small delta, making it really easy to understand when something is broken. Right now, so then what we're going to now need is we're going to need some kind of way to basically say, given your archetype, please tell me I mean, of course we still have all this nonsense of headers, path and the like. We could, and maybe that's what we're going to do, take the easy way out and just copy and paste all this logic. In fact, to be honest, that's exactly what we're going to do. We're just going to take all the logic from here. But of course there's going to be a slight problem. That slight problem is that we do not have state. So the locator is created with state. I mean, it's not nicest design, but this state here contains the main things, and then all the methods just rely on these main things. We don't have that luxury when we're dealing with transforms, because they tend to be static. You could, of course, if you really want to be lazy here, you could, of course, take the whole of the locator as is. And in fact, I think that's exactly what we're going to do. We can keep the locator as private to the class, keep the exact same logic, and then just call the functions based on the enumeration that we just mentioned a second ago. So this really is actually the right thing to do. Now, I'm not saying that if this was not legacy code we would do this, but given what it is, and given our current objectives, this is the right thing to do here. What we'll do is we'll just create a locator in here. and this locator will be implemented exactly as the locator currently is, because as you can imagine this is very quick, and remember our objective is just to get in and out of here as quickly as possible. We're not trying to do anything pretty, we're just trying to make sure that we can get this thing to work without breaking anything. That's the important bit here. Now then, we're going to have this locator class, which is completely private to our transform, as you can see here. Now then, let's make sure we have all the usings. Noise from downstairs. As usual, lots of noise going on. What was he saying? We were saying that we're going to try some very unorthodox surgery here. Let's see what that gives us. We need pretty much everything you see here. Not quite everything, but quite a lot of it. Interesting enough, not quite sure why we're including a model text transform here, but I don't think that does anything. Okay, so, and then finally, if we go back to the enablement transform, if this works, it will actually be really, really good, because it's very low costs. And it will give us more or less what we desire. So what we've done now is we made the locator internal to the transform. I mean, there's other ways of doing this. I could have put locator in the helpers and so on, but the reason why I put it in the transform is because it just reduces the number of legacy classes we got running around. You don't really need to make the diagrams more confusing, the models. The locator will be completely internal to this class, no one needs to know it exists, and so that means a bit less load on our cognitive, a bit less cognitive load. So now we have a locator. The next thing we need to do, let's make sure we're recording, which we are. The next thing we need to do is to try to figure out what to call in the locator and when, right? So we could, well, we can't loop through the formatables model because of course there's no formatables, but what we can do is you can loop through, so something like auto region in m.regions. This is actually going to be a pair. And then if we just do something like auto by reference region pair.seconds, and then for auto. Now I'm not entirely sure what the region has. There you go, artifacts by archetype. So let's call these the region pair, and these the archetype pair. And we should really start using tie. I mean, let me just explain what I mean by this. In fact, to be honest, I might actually just do that right now. So let's structure bindings. See, as you can see here, this is a much better way, because we end up calling all this, creating all these temporary for loop. We end up creating all these temporary variables that are created for no reason at all, and then we just make use of it. I'm sure there must be an example with a for loop. Oh, here we are. This is a much better way of doing things. Let's just try to see what that does. So if I just say something like so logical ID region. I think to type pair. I think there must be a way to unpack a pair. There we are. Okay, so in the particular case of pairs, you need to use different type of brackets, okay? See if that makes it any better. So declaration of variable LID with use type const auto reference requires an initializer. Okay. Oh, actually, I think we're missing something here, aren't we? Oh. So let's just say C++ 17. Well, let's just even say student type pair for loop. Right, there must be a way of doing this. I'm pretty sure I've seen it before. And then you can see why I didn't bother with this before, because of course you end up spending time investigating, going around, faffing around with all this stuff. Right, here we are. Oh, okay. Not ideal. It doesn't seem like there's an obvious way of doing what I'm looking for. I thought that with the new version of C++ it would be possible to unpack the pair directly. Doesn't seem to be the case. We'll give it another minute. Yeah, see, this is what I'd expect to see, something like this. Or even something like this. Right, okay, we ran out of time. We'll have to look at this some other time. It would be nice, but we don't know how to do it just yet, so let's just go on as we were. So if I just have, as I had a region pair, and then I'll have an auto my reference region, and then I'll just basically obtain the region pair second. So now then, what are we doing then? We're basically saying I want the entirety of physical space. I'm going to iterate through each region, get the region, and then in that region get the archetypes, and then I think I might just call this arcs because we know what it means. That's going to be paired. Oops, pair dot second. Right, now I've got an archetype, right? Now what I now need to do is I need to do something like get archetype kind, something like this. Oh, we don't need the word legacy in here. So I just need some kind of way of doing a get archetype kinds, and then I need to obtain something like the archetypes meta. Is this a pointer perhaps? Okay, good. It is a pointer, so if I just obtain the artifact. And the artifact, if I just say do I have an artifact here? It is a pointer, so I'm not entirely sure why I'm not able to. Oh yeah, meta name. Right, so here we are. So I need something where I supply a meta ID, and then I get an archetype kind. Then I switch on the archetype kind. Whatever. I do something based on that. Populate the path, populate the includes, and away we go. I also need to know if an archetype is requires an inclusion path. And the way we do that is there's a property somewhere in the archetype that tells us that. Relations, operation. There's far too many kinds and types and things like that at the moment. Just literally the lack of clarity of the model, and that's expected. I was quite sure we had a property for this. So let's think about this for a second. Oh, actually, I think sadly the property is going to be in the model to text transform. Okay, cool. We could do the same thing. Right, let's think about this for a second. So the property is in the model to text transform at present. It's obtained. So if I take any transform, I shall see that there is a inclusion support types method. But then we made some changes actually to the meta model to include some property. I believe it's a label, in fact. There is a label somewhere. And that label is applied to the archetype. So, okay, we probably will start with a hack, and then we may replace that with something that's a bit more sensible. Because at the moment we know how to identify the archetype kind. We know that all the archetype kinds that are of type C++ header, C++, which we don't seem to have one at the moment actually. Just as I say that. Yeah, C++ implementation, but I don't see C++ header, so let's just add one here. Now, like I said in the past, I tend not to rewrite history so much, but only in certain cases where I think it's just there's no value of creating a new commit. It's trivial, then don't bother. This is one of those cases where really what we meant to do was to generate the enum with the right things on it. We didn't. So what we should do is just recommit the commit, make sure the tests pass, and you don't, but for different reasons. No, don't seem to be able to change areas while committing. Let's just I'm not entirely sure we'll be able to commit or to run the tests with this stuff. Let's see now. Make sure the tests are green. So okay, so what we're gonna do now is we'll do this. Even the hack is gonna be done in 2 stages really. First we'll just do the first quick hack stage. Okay, interesting enough, we're seeing diffs. Not entirely sure why. Most interesting. Oh, I think we just forgot to code generate actually. Classic. Yeah, we forgot to code generate. She's fantastic. We'll pass now. Yep. Right, now then, so where were we? We were here. What was I trying to say? I was trying to say that we can easily now, so we can easily create a function like this guy here that simply obtains something like identification, entities, physical meta ID, obviously so const, and it returns something like legacy archetype kind, and that will be available somewhere in the physical model entities, most likely. Presumably we need... Right, so what we're doing then, legacy archetype kind not found. Sadly, we're not the best spellers in the world, so... Peculiar. What? Clearly there's spelling error somewhere. Similar. It's actually worrying because I think the spelling error is on the type itself. Archetype, of course. Well, yet again, we will have to regenerate this. So, after all of that, of me saying so many times that we don't really uncommit the committed code, we just did that about 10 times. Just to show you need to be flexible with your principles. Now we are very, very confident that this is just going to pass, so I'm not going to bother running the tests. Probably not something you should do. Right, so now then, transforms, pass, okay, fine. Right, so where are we then? Once more we try to get the archetype kind. Righty, so, so the job of this function will be very, very simple. One big hack. Please tell me what it is that my kind is. And we will just return you the kind. I believe we already have identification. Namespaces, or the type at least. So we can get away with that. Okay. Now we just have to do one big if. So if PM ID dot value. Well, to be honest, let's just basically say const out of v. V equals. And now we're just gonna have to create a few of these kinds. So now, just think about this. What's the easiest way to do this? I mean, we could include what we haven't got access to text model. So, we probably what's the easiest way to obtain a listing of the archetypes? Clearly, they exist here in the text model. C++. Probably, I suspect the quickest way might be to just hop over to JSON. Let's just create a new area here. Let's call this Dogen models. So what we'll do is we just go over here to the models, maybe JSON, text.cpp. Right, now then, quickest way to obtain all the archetypes has to be some kind of JQ transform over this model. So if I ask for the names, let's have a look. So if I just do something, in fact let's just do JQ interactively because this is small enough. So just ask for all my elements. And then in the elements, what do I need? I need to name, I guess. Right, so this gives us faq_elements.name. Okay, that should probably do it. So faq.elements.name, and then just make this JSON merge for a laugh. Now then, if I just then say, wonder what's the easiest way to filter out to just get the archetypes. Well, actually, presumably they'll all be under transforms, so we can easily say sort. Okay, that's good. So now, with the sort, we can get rid of pretty much anything that's not under transforms. Now, even in the transforms, we're going to have a few things that are still not needed. In fact, I think we might just be able to get away with removing them by hand, because I don't think we have any archetypes outside of the facets themselves. Maybe lying, but these are transforms. Yeah, I think all the archetypes are inside of facets. So, well, even then, we might end up with one or two things that we can't do in an automated way. But I think the vast majority of them will probably work. So then, if we then say all the ones that are at the top level in transforms are not particularly useful either. So well, I'll say this is definitely one good one. This is not needed. All of the IOs, lexical cast, that's a facet, we need these. Right, another thing we don't need is traits. I'm gonna have quite a few of these, so if I just then say v traits, that's a whole bunch gone as well. And then finally project. This is, I think, a namespace, so I think we can get rid of all of this. And then oh, can get rid of all the initializers as well. Oops. Okay. Workflows, well, transform. Right, okay, I think we've done probably enough now. Just have to pick up the stragglers now. There'll be a few things here which are probably quite obvious because most of them will only have one level of namespaces, I think. So, in fact, that is quite a good point. So we can easily now do something really simple. We can now say, because we assume that all of these will be in facets, we could probably get rid of, well, first let's get rid of transforms, because I think that's going to make things much clearer. In fact, we don't really need quotes either. Right, so now then. Okay, we need to get rid of all the helpers because those, although having said that, yes, the helpers don't generate, yeah, that's cool, that's correct. So, get -v helper. Okay, now then. I think we're very close to it now. Let's just make sure. So I think anything here now that does not have a namespace is not needed. In other words, we need to grep for a namespace. Okay, that's good. And whatever is left, I think, is good. I should think. Okay, cool. Now then, now we just need to group these things here. And I think the obvious grouping is going to be implementation in header. That's going to give us a lot of bang for the buck. So if there was an easy way to sort, let's see if a sort separator. Okay. Let's see what happens if we try something like this. Sorts minus, and the separator now is going to be the underscore. But there's a problem. We're gonna have. We need to know. Is there a way of saying sort last field, whatever that field is? Yes, the best way to do this is going to be using awk, and now it's going to be a bit annoying. Okay, right, so let's try to find an easier way of doing this. Well, actually, one possible way of doing it is to just filter things out with words like header. So we could say, first let's keep these lists, because I think this list is very close to what we want. So let's write this down. Oops, sorry, we are still in a sort here. So let's just go to, say, templates, and let's just create here a temp.txt. Right, so this is going to be our original. Now, if we just do something like grep for, actually, now we've done that, let's just go back to where things were. Right, so what did we call that file? temp.txt. Right, so now then, let's just grep for header. Okay, so this contains all of our headers. And if we just go back to where we were, we can create a whole bunch of headers here. Now, I wonder if we should even bother with the facets, actually. Part of me just says, well, if you have the same name, it's bound to be a header. Just, in fact, that's exactly right. So what we're going to do is we're just going to one more level here of filtering. Let's just do something like this. Let's awk. So if we say to Hawk that the field separator is ::, and if we just print $2, and if we sort that, and then if we just unique it, slight bug. Just forgot. Not quite sure what's going on at the moment, but so awk, doesn't really matter. Awk. What's this? Yes, here we are. This is what, as I mentioned quite a few times here already, trouble of recording while thinking, that your brain does not function. Let's look at this more carefully then. Awk, begin, field separator is now this guy, print, right, okay, cool. There we are. And now what we can do is we could basically say, let's just create a quick macro. So costs to string by reference, archetype kind, and then if we just actually think actually we shouldn't really use by reference here, but it doesn't really matter. We just leave that with a macro. Right, so what we're going to do here is we're just going to create a whole lot of string constants just for now, and let's just get rid of that by reference before it causes problems. Right, there we go. And now we just need to say something like one thing I think we're going to have problems with is we kind of needed all of them. I guess we can go back to this guy here. Right, now what we need to do is oh, actually we're in the wrong place. So if v, right, so we're going to do that. We're going to do something like this. So if v equals aka or, and that should cover most cases. Right, so as you can see here, very simply we could basically say if you're one of these archetypes, just return the one we just added, which is the header. Okay, just return C++ header, whatever that is. I think LSP is a bit upset at the moment, actually. Not really giving me any error information. Let's have a look. Error from the language server. Non-added document. Okay, so what we're going to do is, sometimes LSP gets a little bit upset like this. What it tends to help is to just do a quick reload of the document, and LSP then sorts itself out. Right, okay, so you can see here we can just use this approach, and then we can simply say case this guy, then we probably need some kind of using here as well, which basically means we should really do a using at the very top. I actually like doing my using statements all next to each other, but there you are. No, here we should probably just throw invalid archetype kind. And this could just be PMID. This will be PMID not value. Righty, so this looks good. Make sure we have a throw exception. We do. That's here. We can just put one of these guys. Archetype does not have a kind. Okay. Ready. Okay, now then. So we go to this massive switch statement. We get an archetype kind via the ID. We must make sure it's a static function. Yep, so there you are, very simple. We get the ID, we get the archetype kind, we switch, probably want the default here somewhere. We could just say invalid archetype kind. Probably should say AK, I guess. Actually, just leave it for now because we're gonna have to use lexical cast. We got that already. We're gonna need IO for the archetype kinds. Legacy. And we're also gonna need whatever that thing was. Well, missing is really not the right word. Invalid, that was the one. So archetype kind is not supported. So it's always good whenever you, for every type of handling that we do, just assume that if something is unexpected, just throw. What we can do in this case is just create a stream. Well, should we do a stream or boost lexical cast, I guess? Ghost auto archetype kind. No, can we have an archetype kind? Let's just use a stream. So if I just say something like sudo string stream os, because if I just do this, I don't even need to bother with the lexical cast. And I can just say AK, and then I can say const auto MSG os.str. We should really have helpers with all this sort of stuff, but as I always say, not enough hours in the day for all this sort of stuff. That's the reality of development versus the theory, I think. Righty, okay then. So here's a very simple approach for this thing then. We just need to create a locator. So locator L of M. Probably const, to be honest. And then once we've got one of these guys, well, we know your header. So then what we do, we have an archetype. And we need to compute file path, presumably. And that could literally be L not. And we can just make full path C++ header. And the logical name is going to be in the region, presumably. Right, so we're probably going to need some. It's interesting that we ask for. Oh yeah, of course we ask for the archetype. That's fine. So let's just obtain. Yeah, so this is a bit wrong, really. So this should be the artifact pair. The artifact is here. Now we can get the physical model ID. Let's think about this then. So we just need to compute the path for this archetype. And we just need 2 bits of information. The first thing is we need to have the physical model ID, or logical model ID, should I say? So region dot provenance dot logical name. So const auto by reference logical name. And we up. So just need the logical name, and we also need the archetype, which is going to be something like const auto by reference logic physical meta ID. So this guy will convert the physical meta ID into something we could use. And this guy will compute, given the logical name, and PMID. Now, of course, sadly, the locator is not clever enough to use PMID, so we put a value here. I could update this, but right, there we are. So very, very, very simple. However, there's going to be a problem. The problem is going to be that the archetypes are PMIDs. So this won't work exactly as is. We need some kind of way of obtaining from the PMID. We just want the last bit. So really, we don't really want the PMID at all. We will want something like I think about this. Meta name. So I think it's meta name dot archetype, presumably. Yes. Okay. So if we just do this, if we just obtain the archetype, so we're just going to change this slightly here. Let's call this archetype name, maybe. It's all getting a little bit out of control, the hackery, but as long as we keep the gist of it. Right, what we're going to do then is we're going to say this guy is just going to contain the archetype name, and we probably get rid of this, and then if we just replace V with something like this. Okay, so now then, this is the archetype name. This thing here is going to obtain the constant auto archetype name. And here, we just use the archetype name. Right, okay. Huge amounts of hackery going on here, but I think the gist of it is correct. Okay, we still seem to be struggling with LSP at the moment, so we'll look at that in a second. What I really care about is that we got to core of the algorithm right, if you could call it an algorithm. Right, so then we now have, for each of these things, we now have to locate the things that we're looking for. So let's go back to our lovely document. Can't quite remember where we left it, models perhaps. So we got the headers, so what we can do now is we can basically say grep minus v header. Then seems like the vast majority of these are now implementation. So let's just grab implementation. Could use the same process we did a second ago to extract only the ones we care about. Probably should have done all these in one go, I guess, but so const string AK so this will create. Right, LSB is now decided to kick in whilst we're trying to run a macro. Right, I can see the word transform somewhere. It's probably alright, I think, because let's go back to where we were a second ago. So that's fine, that's fine, that's fine, that's fine. All the transforms are fine. So then we go back to this guy here and say grab -v implementation. Right, so whatever is left now is going to be the odd ones out, I think. Let's take these guys. I don't really like when we go too far in terms of the columns, so sadly I'm going to have to do some manual hackery here. Doing for time. Already past an hour. So it's in a way this is a good demonstration. A lot of people think of programming a lot of glorious activity of the brain, but in reality a lot of times programming ends up being huge amount of stuff like this, drudgery really. Not particularly exciting stuff. Now then, if you could just return C++ implementation, that would be helpful. Okay, so now we have to be very careful here because so this is where things are going to break, as you can imagine. I'm taking a very simplistic approach of all of this. In a second we'll create a function for this, but the simplistic approach we're taking at the moment is that we're assuming that all implementations are the same, but there are different implementations. For example, we'll see that there's a main. Well, it's not under implementation as it happens. There will be lots of odd cases that are just going to break, and we hopefully will see this in terms of the paths. Now let's just break whatever is left into groups. So for example, for declarations, do we have a special case for forward declarations? I'm pretty sure we do. Doesn't look like it. So that means we could add the forward declarations to could probably add the forward declarations to the existing code for headers to make our life easier. So our usual is in fact only 2 of these. And in this case, it actually is probably easier to just do these things by hand. Righty. So I now need seems to be a bit unhappy. Not sure why Max isn't happy at the moment. think LSP is going a little bit crazy at the moment. And this tends to happen, to be fair, this does tend to happen if you start abusing the sizes of things. Like you can see we're creating hundreds of constants and things like that. I think it does tend to make LSP go a bit crazy. And in this case, it's sadly nothing else you can do other than every so often open the file and close it again. Right, for example, why is OR no longer working? Not too sure. Right, so let's just do a refresh of this file again. LSP seems to have recovered. I have no idea why this happens every so often. I'm not sure if it's LSP, if it's Emacs, what it is really. But it seems to get into a bit of state after you start making files that are a bit complicated. Right, now then, this is the for declarations, although, easy to for declarations, right, so. Right, so more of these. For declarations are also headers. As you can see, this is one big sort of hack. But the key thing to remember is that all of this will be data in the future, and making life much easier now, because what we're doing here by hand is what we were doing in the data-driven model, but by introspecting, asking the artifacts about these things. So whilst this may look very bad, it's actually a step in the right direction. A bit of noise coming from my right, cool. So again, let's go back to our models, was it? Not the best name area. Now we seem to be really down to the end now. So I don't think we need any of these prefixes, and I don't think sorting is gonna help. So these are different unique things that we need to capture. So hopefully all goes according to plan. Each of these will be a type. In fact, it's not quite true. That's fine. Let's just. In fact, we can't do this. Sorry, let's start a macro again. So constant string. Okey-doke. Right, so these guys here probably will, each of these will have their own type. Most of them anyway. So if I go back to the original list, let's see. First thing we need to know is how do the options work? Right, so don't seem to be treating them very specially, so we'll just treat them as a group. So what we'll do instead is for each of these, let's see what we got here. Else if okay. And this guy Right, so then, so if you're a CMake list, we should just return CMake lists. So interestingly enough, we have three different kinds of CMake lists. I'm not too sure why. Oh yes, okay. Okay, no problems. The slight problem is we don't really have an easy way to distinguish between the archetypes. Now that is going to be a problem. Because actually, see, this is really bad modeling, really. It's because the archetype, we need the facet as well as the archetype. In fact, I'm not even sure if that would be sufficient. Let's have a look how these things came to be. So we should have a facet for all the CMake list stuff. Not sure where. Okay. Not sure why I can't see the CMake list stuff. Should be here. Start from the beginning. So around here somewhere there should be some kind of build facet perhaps. Let's have a look. This is clearly the types facet, this is the biggest one. Then build, there we are. Oh, okay, right, so here we are. Clearly we have an include CMake list and a source CMake list. Now I'm not entirely sure why we ended up with just the one CMake list. Not too sure. But nonetheless, we did do a lot of Unix faffing around. I'm not surprised that there are problems. So let's just say, in fact, to be honest, as you can imagine, in a second, oh, sorry. In a second, once we try to run this, we're gonna have a lot of errors, and you know that's fine. That's expected, really. That's how we roll. Right. So one of these is gonna be source. The other one's gonna be include. And we're gonna have to. Now let's just make sure that our physical enum contains two types of CMake lists. We have test CMake lists as well. Now that is peculiar because I don't remember seeing that. Only two types here. Let's go to tests. Yes, okay, so that is really not ideal, but fine. We have three types of these. Good lord. Okay, so what we're going to do then is yet another big hack. We're going to create a test CMake lists. That is actually just CMake lists. Not ideal, but so then the idea here is going to be that we, for each of these, include source and tests. Tests. Okay. Next, so logic list templates. So hopefully I'm going to end up with a logic list templates. Alright, so we don't have a logic list template, we have templates. It's a bit worrying. Well, for now, let's leave it as it is. Main. Right, so that's definitely going to be a problem because there's several types of mains and we can't distinguish between them. So if there is main So there's a tests main. We don't seem to have any other. Okay, fine. So clearly this is going to be quite problematic in a minute, but let's deal with the problems when they come. And right, so then we just need to deal with these options. Righty. Okay, right now. So well, to be honest, in certain cases I don't even bother with that. Let's just return something here. Right, okay, so then this is going to be some kind of project. This is going to be some kind of solution. Okay, cool. So we don't know for sure that there's going to be lots of problems here, but let's just see how far we've got. Best thing to do is to start off from physical, and let's just go in order of what we see here. So Visual Studio Solution. So case. Actually, sorry, I'm just gonna make mine up a bit easier. So if you're a Visual Studio Solution, I expect something like Visual Studio Solution, and the rest is going to be that. Very long call, annoyingly. Right, that's the first one. Next is the project. Which I hope is going to be just project. Next is ODB options. Hopefully it will also be very simple. Okay. Full path for ODB options. Now of course you must remember we are not dealing with the relative paths just yet, so it's going to be another level of pain. But as always, best confuse one issue at a time. Just need this to do something sensible. And let's build targets. Followed by test CMake list. So we got the 3 CMake lists coming through. Perhaps you could just do all of them in one go. Don't think we've done them yet. Right, so then right, so what we want here then is to say tests, CMake lists. And here we want to say source. And here we want to finally say include. Right, that's the CMake list. Then we have header implementation. Okay, followed by test CPP main, test CPP implementation. These are going to be interesting. And the templates. Now, problem we're going to have, of course, is that we have no way of knowing whether you're CPP main or not. But doesn't really matter. We assume now. However, we've done this that we can just assume if you're main, you're a test CPP main. This will break probably if your assumption is incorrect. Test CPP implementation. Okie doke. Finally, we have the templates. Right, so as you can see, huge amounts of hackery and hard coding. But all in all, our original idea, our original intuition is more or less correct. These huge amounts of hackery and hard coding more or less maps all the external calls that we had in locator. They kind of seem to map more or less. So okay, I mean, I'm sure there's going to be lots of problems here, but it's fine. At least we got the gist of the implementation. Now let's just think about what we've just done. How are we doing for time? Approaching 1.5 hours. Right, so what did we do then? We took all of the artifacts in the model, we mapped those artifacts to a kind, and using those kinds we dispatched to the appropriate call in the locator. This is in fact what it does is it replaces the existing functionality where we're using the locator via the text transforms to obtain a path. And the reason why we want to do that is because we want to move away from the existing legacy code in the Formatables namespace, and we want to use the new data structures. So if all goes according to plan, this will then enable us to remove this guy here. Now it's not going to enable us to remove this guy here because we're not calculating the include paths just yet, but we're halfway there. So let's see what happens then. In fact, to be honest, I think we might this will be a very long video if we now attempt to fix all the errors. So what we'll do instead is we will just disable this transform. I mean, this will break a lot of things, I think. What might even work by sheer luck, actually, it just disables it just goes approve. Okay, interesting. Okay, before we do anything else, well, to be fair, as I said, this is going to take a long time to debug. So what we're going to do instead is we will get something out of this by disabling this in the main chain. I'm going to run all tests, make sure everything passes. So this means the code is going to compile, but it's not actually going to kick in. And sometimes I actually quite like doing things like this because, look, sometimes you just need to get step by step, right? And we've done a whole lot of changes here, a lot of modifications. Look, the code compiles. This is good enough to commit. Make sure it's just not being used, and one will be happy. So that being the case, we could say something like physical first stab at implementing legacy paths transform. And that's fine, it's perfectly reasonable thing to commit. Probably need a break as well, so might as well clock this out. Okay, so this is good. So we've done a good bit of work. We've done our first pass basically at implementing this transform. Now we know there's going to be lots of problems. This is just expected. We just go to the usual thing. First, we have to debug. Debug print, dump stuff to the log file, understand what these archetype names are, massage the strings a little bit, then start computing the paths, try to understand what's happening here with the full path. Then at some point what we'll do is, once you're confident enough with, we'll go to the existing transform, probably call something like full path transform, I believe, path and file and path from guard, and then all we need to do is to comment out this bit here where we're computing the file path, and that would then kick in the new transform, and then lots of errors will come up, lots of diffs. We go fix through those, and eventually we'll be able to remove this bit. Then once we're done with that, we start computing the inclusion. Similar exercise, eventually we'll be able to remove the whole transform plus the locator. Okay, so this is, since we already are getting close to 1 hour and 40 minutes, I think we'll just call it a day for this part. Thanks for watching.